Page 6 of linear modeling. Let's see, the table below shows the amount of time a collection of families spend preparing homemade meals each week and the amount of money they spend each week on fast food. Okay, there's probably a relationship between those two, right? So, luckily we're not going to be graphing anything, so we're just going to be using the calculator to find R and find the linear regression line. The easiest part of this unit, and also the part that is definitely going to appear on the exam if they're going to have linear regression. Okay, so first thing is when you look at the data, they were really nice to us this time. They actually said X and Y in the titles. So now you know which one goes in L1, and which one's X, and which one goes in L2, which one's Y. But even if they didn't tell us what X and Y were, remember that they're not trying to be tricky. The first one is going to be X, and the second one is going to be Y 95% of the time. Okay? So we're going to type in our X data into L1 and our Y data into L2. Remember that if you have data already in L1 or L2, you just move the cursor up to L1 and press clear, not delete, and then it'll clear out the L1, and then you can type in your data. I'm going to type it in right now. I'm just going to pause the video so that when I come back, everything's all done. Okay, I've typed in my L1 and L2. Now I just need to make sure that Stat Diagnostics is on. So I press Mode, and I go down to Stat Diagnostics. Yes, it is on. Good. Then I'm going to do Stat Calc Lin Reg to find the value of R. Stat Calc Lin Reg. Enter. L1 and L2 is already an X list, Y list. Perfect. Go down to Calculate, press Enter. And the R value is negative 0.8678. So I'm going to write that down. Negative 0.877. 868, right? And remember, if it's between negative 0.5 and negative 0.87, it's considered moderate, right? So it's moderate, and it is negative, right? What does it negative mean? It means that the two factors are negatively correlated, which means that when the time on homemade meals goes up, the money on fast food goes down. The more time you spend making homemade meals, the less money you spend on fast food. That makes sense, right? Then it says to find the equation of the least squares regression line. That would be the A and the B here. Now we're just going to fill the A and B into this equation, y equals ax plus b. So they're just telling you what to do. You don't need to write down all the digits. This 3 sig figs is fine. So I'm going to write y equals negative 12.7x and then plus 116. Okay. Let me just put the plus sign in the middle. Okay. Notice that the negative sign on the slope also corresponds to the negative sign here. So when you have a negative R value, your slope value is also negative. All right. Interpret the gradient and the y-intercept of the least squares regression line. This is something that they will ask you on the exam, and it's something you should do for the IA also. So the 116 here is the y-intercept. Remember, the y-intercept occurs when the x value is 0. So when the time on homemade meals is 0, then the money spent on fast food is $116. Okay, so that's what the y-intercept means. What does the gradient mean? The gradient means that for every certain x value, a y value changes. So like, for example, if the time on homemade meals goes up 1 hour, then the money on fast food goes down $12.70. Okay, so if the time on homemade meals goes up 1 hour, then the money spent on fast food goes down $12.70. So that's what negative 12.7 slope means. Another family spends 5 hours per week preparing homemade meals. Estimate how much money they spend on fast food each week. Comment on the reliability of your estimate. Okay, so here they're giving us a value, 5. Do we put that in for the x or do we put that in for the y? So 5 hours is time preparing meals, so that would be an x value. So we're going to plug the 5 in to the x. And that is going to help us find a corresponding y value. Okay, so let's do that. We're going to use the calculator, and then we're just going to do negative 12.7 times 5 plus 116. And we're going to see for somebody who spends 5 hours per week preparing homemade meals that they're going to spend $52.50 on fast food each week. Okay, comment on the reliability of your estimate. I would say it's reliable, and there's 2 reasons for that. Number 1, we have moderate R value. Okay, so our correlation is moderate, so that means it's pretty good. The other thing we can say is that the 5 hours is within our data interval. Okay, so 5 hours is within our data sample interval. So that means that we are interpolating, and interpolation is more reliable. Okay, so you should mention both of those things, that the R value is moderate and that we're interpolating. Okay, let's move on to the next one. Once a balloon has blown up, it slowly starts to deflate. A balloon's diameter was recorded at various times after it was blown up. So we have time for our first data set and diameter for our second data set. You don't even need to think about it. Assume 95% of the time that the first data set is L1 and X, and the second data set is L2 and Y. Okay? Describe the correlation between D and T. Okay, so we're going to have to describe the correlation between D and T. They want us to find the R value and then comment on it. So we're going to have to put this into StatCalc and Reg. So let's go ahead and do that. I'm going to turn the video off, and then I'm going to type everything into Stat Edit. Just to remind you, when you do Stat Edit and you want to clear data out, you just put the cursor on top of L1 and L2 and you press clear, not delete. I'll be back in a second. Okay, here we got our data typed in. Let's do Stat Calc Lin Reg. Of course, we have Stat Diagnostics already on because we just checked it before our first problem. And here is our R value. It's negative 0.998. So negative 0.998, we're going to describe the correlation as negative and very strong, right? Because since it's between 0.95 and 1, it's very strong. If it was between 0.87 and 0.95, then we would just say strong. Okay, so that's the correlation. Find the equation of the least squares regression line. We can just write that from looking at the A and the B values here, right? Y equals negative 0.232x plus 39.966 would round up to 30. It would be 40.0, right? Okay, that's the equation of the least squares line. Use this equation to predict the diameter of the balloon after 80 hours. So if I put in 80 in for which would it be X or Y? Time is X. So I would put 80 in for X. And so that would be something I'd have to do on the calculator. I'm just going to type in the calculator. I'll be right back. Okay, I just typed it in. Negative 0.232 times 80 plus 40. And the answer is 21.44. 21.4. This is the diameter of the balloon after 80 hours. That's answering the first question. The second question, the time it took for the balloon to completely deflate. So the time it took for the balloon to completely deflate, in this case, they want to know what T is, right? T is what they want to know. Completely deflate corresponds to a diameter that they didn't tell us specifically what it is, but wouldn't it be diameter of 0, right? So in this case, they're giving us that the y is equal to 0, and they want us to find the x. Okay, so what's the easiest way to do that with the calculator? Well, you don't even have to do algebra. I could go over to y1, and I could put negative 0.232x plus 40 into the calculator, and then graph it. Okay, unfortunately there was a weird zoom here. Let me change the window so that it follows this data here. So the x values go from like 0 to 110. So I'll put like 0 for the x min, and I'll put 110 for the x max. And then for the y min and the y max, I'll put, I don't know, 0 to, what's the biggest number here? It's like 40, so I'll put 0 to 50. Okay, and then I'll graph. Okay, negative correlation, so that makes sense, right? It's going down. And we want to know when the diameter, when the diameter of the balloon is 0. Oh, so the diameter, remember, is the y value. So the y value being 0 is the x-intercept, and we can't even see the x-intercept right now. Let's make the x max a little bit bigger so that we can see it. I'll put it 190. And then we're going to find the x-intercept. The x-intercept can be found by doing second calc 0. Well, x-intercept is a little bit tricky because the keyword of 0 doesn't necessarily remind students of x-intercept. So the left bound, we'll just hit enter to the left of the x-intercept, and then we'll go slightly to the right of the x-intercept. We went past it. That's what we want to do, and we hit guess. And our answer is 172. 172. So it takes 172, I don't know, minutes maybe, 172 hours? 172 hours for the balloon to completely deflate. Okay. Which of your predictions in D is more likely to be reliable? So in both cases, we're talking about very strong correlation. So that's not different, right? The difference between making this prediction that after 80 hours, it's 21.4 in diameter, and making the prediction that after 172 hours, it's 0. Notice that the second prediction, 172 hours and 0 in diameter, is like outside of our data cluster, right? Our data is like all over here. By the way, there's a way we can show the data. If we turn and this is not something you need to know for our class, but sometimes you're going to use it for science class. You can turn on the data points by going into plot one off, and then hitting enter, and then going over to where it says on off and press on, and then it's already in scatter and everything. And then when you graph now, it's actually going to show you your data cluster. And notice our data cluster kind of ends here. And the prediction we make about 80 hours, that's well within our data cluster. It's around here. So that's pretty reliable. This prediction with 172 hours and 0 in diameter is like way over here. So it's outside the data cluster. And that's why it's less likely to be reliable. Okay? All right, last problem on this page, number 7. This is a challenging one. I'm going to type this data in offline into stat edit, and then I'll be back to run stat calc reg with you. Okay, I typed in my data into L1 and L2. On this problem, the first thing they ask me is not about R. They ask us, what is the effect on Q as T increases? And then they ask is the graph linear. So that's a little bit sus, isn't it? So if we look at our data, remember that we have a way of just looking at the dots without even doing lin/reg first. So why don't we do that just to see what it looks like? They ask us if it's linear, right? And by the way, there's a special zoom we can do. Oops, there's a special zoom we can do if you press zoom called zoom stat. And if you do zoom stat, it'll actually do the window so that it shows the points. Oh, look at that. Isn't that nice? Okay, so do you see that the points are a little bit curvy? Maybe it looks like, I don't know, like an exponential or something. It doesn't look necessarily like a line because it's so nicely curved. So the effect of Q as t increases, remember Q is the y and then t is the x. So it seems like the effect of time, years, causes the chemical Q to decrease. It decreases, but it decreases in a curve. So is the graph linear? It doesn't appear to be necessarily linear. It looks like maybe there's an asymptote or something here. We don't know, right? Construct a table of values comparing Q with square root of t. Okay, so they're giving us a proposal that maybe Q is linear with square root of t instead of with t. So there's a way to do that easily. Now that you already put everything into stat edit, we could take all of our values of t, which are this first row, and we could change them to square root of t. You can like put the cursor on top of L3 and I can put square root of L1 and it'll change all the values from L1 to L3 taking the square root. So let's do that. I'm going to put square root, which is right here, L1, which I'm going to do by doing second 1, and then hit enter, and it's going to take the square root of all these values and put them into L3 right away. Isn't that great? Okay, so now we have a table with square root of t in L3, and we have our Q values in L2. Okay, so now we have that table. What are we going to do with that? We're going to explain why Q equals m square root of t is a likely model for the original data. Okay, probably they want us to graph L3 and L2 now, so we'll do another stat plot, except this time with the stat plot, we're going to change it to L3 and L2. So we're going to go down here for the X list, and instead of L1, we're going to put L3, and then we're going to graph again. I don't know if we're going to have to do stat plot again. Oh yeah, maybe we're going to do zoom stat again. So let's do zoom stat one more time, which is number 9. And then, there we go. Now it's pretty linear, isn't it? Okay, so the reason why Q equals m square root of t plus c is a likely model is because it looks like a line, right? And look, this is y equals mx plus c. Mx plus c is a linear model. When we make x into square root of t, it looks linear. So that's why it's a likely model. Use your calculator to find m and c. Okay, now we're going to do stat calc lin reg. So we do stat calc lin reg number 4 and calculate. And we have negative 1.07. Let's see. I'm going to do this. Oops. We're going to do this. We're going to have Q equals negative 1.08 square root of t plus 109. Okay. So our m value is this, and our c value is this. Find the quantity of chemical in a newborn baby and a 25-year-old. So now what they want us to do is they want us to use this equation to find the Q for time equals newborn baby would be t equals 0 and t equals 25. Okay, and then so we're going to do that by substituting in. Oh, by the way, what was our value? It was very good, right? It was negative 0.976. Okay, so very strong, right? So let's use our equation here to find out the Q for newborn baby and t equals 25. We don't even need to use a calculator to find for newborn baby, because if we put 0 here, m times 0 is 0. So basically, the newborn baby Q would be 109. It's the y-intercept, right? What about when t equals 25? So then we would put 25 in for t, and that would be square root of 25, so it would be 5. 5 times negative 1.08. So it would be negative 1.08 times 5 plus 109, 103.6. So for a 25-year-old, what we would expect for the quantity of chemical Q is 103.6. Are the answers in F likely to be reliable? Fairly reliable, right? Because number one, the R value is very strong, right? It's negative, very strong. So that's one reason why it would be reliable. 25 is definitely within the data cluster. So that's another reason why the prediction for 25 would be reliable. Even though 0 is not in the data cluster, it is very close to being in the data cluster, right? 0 is very close. But maybe you can make the argument that 0 is not in the data interval, so it's not as reliable.